Okay, quiz tomorrow. It's going to be looking very, very similar to what we have here. The first thing we need to do is tell whether the function represents exponential growth or exponential decay. And this is really, really super simple. All we're going to be doing here is we're going to be looking at this number right there. If that number is greater than 1, we're going to be exponential growth. 4/3 is definitely bigger than 1. If you don't believe me, you can type it into a calculator. 4/3, hey, that's bigger than 1, so this is exponential growth, and I'm just going to write growth right here. This is 5 times 3 raised to the x power. If you can't read that right there, again, that's 5 times 3 raised to the x. Okay, this number right here is what we're looking at. 3, definitely bigger than 1. So again, this is growth. Now here's where the trick comes in. Whoops, I spelled that incorrectly. That's a TH. This is 3, 2 to the negative x power. So what happens, remember when you have 2 to a negative exponent, again, this is 3 times 2 to the negative x plus 2. That's what that's reading as. You need to change this, and this becomes, and we're going to write it right up here, f of x is 3, and then the 2 to the negative x becomes 1/2 raised to the positive x, and then plus 2. And clearly then 1/2 is less than 1, and so this is exponential decay. So now let's get into the good stuff. A diamond ring was purchased 20 years ago for $650. The value of the ring increased by 6.25% each year. What is the value of the ring today? Now for this one, since we are increasing, the exponential function we're going to use is y is equal to a times 1 plus r raised to the t power, where again a is your initial value, r is your rate, expressed as a decimal, t is the time in years. Right? And I know that we're going to be doing the plus and not the minus because we're increasing in value. So what is the value of the ring today? Well, y is equal, it began its value at 650, so I'm plugging 650 in for the a, times 1 plus the rate in this case is 6.25%. Now 6.25% expressed as a decimal, we're going to move the decimal place one time, 2 times. Right there. So we're going to have 0.0625. So 0.0625 and then raised to the t power. Now t is time in years, and you'll notice it says it was purchased 20 years ago. So if you want the value today, we're going to plug 20 in for t. So over here, 650, parentheses, 1 plus 0.0625. Close your parentheses, and then raise that to the 20th power. And so we're getting 2,000. The value of the ring in dollars is $2,185. And if we round, we're not going to round this to 21 cents because that's a 4 right there. So 20 cents. It says write an exponential, that should say function, that models the value of the ring after t years of purchase. So it's basically the same thing. Y is equal to, this is still part of number 4. And again, the initial value was 650. We just want to simplify this right here. 1 plus 0.0625 is 1.0625. And then it's t years after purchase. So we're just not going to plug that 20 in for t. We're just going to leave it like that. Okay, you deposit $15,000 in an account that earns 4.75% annual interest. Find the balance after 8 years if the interest is compounded with the given frequency, and I tell you monthly. Okay. Now in this case, since we're doing compounded interest, we're going to use the formula that will be given to you tomorrow. A is equal to P times 1 plus R over N raised to the NT. This formula will be given to you. The formula up here you have to remember, okay? But this one's going to be given to you. So we're trying to find an amount. We invested $15,000, so there's my 15,000, times 1 plus, that never changes. Now the rate. The rate was 4.75%. So 4.75% to change into a decimal, 1, 2. And so the rate is 0.0475 over. Now n is the number of times it's compounded per year. And since we're monthly, n is equal to 12. So we'll put a 12 here, close the parentheses, and then in the exponent, n is still 12. And now we need to figure out the time in years. We're looking, oh, there it is right there, 8 years. 12 times 8. So in our calculators, 15, 1, 2, 3, whoops, 1 too many zeros, there we go. 1 plus 0.0475 divided by 12, and then we're going to raise that to the 12 times 8. And so we're getting the value of the ring is $21,917. And we're not going to round this 2 up because that's a 2. Excuse me, that's not supposed to be a comma. Let me change that right there. And so $21,917.82. Okay. Todd and Dye business purchases a piece of equipment for $175,000. The value of the equipment depreciates. Remember, depreciate means it's going down, okay, at a rate of 13% each year. We want to write an exponential decay model, and this is another one that you have to remember. If it's going down, okay, y, the value is going to equal the initial amount times 1 minus r raised to the t power. Remember, if it's going down, it's minus. It's the same formula as what was written here, except the plus changes to a minus. So we'll have y equals, it was purchased for $175,000. We're going to do 1 minus 13% as a decimal. Move the decimal point over 1, 2. And so it's 0.13 raised to the t power. And so what is the value of the equipment after 7 years? You're just going to plug 7 up in there. Y is equal to 175,000 times 1 minus 0.13 raised to the 7th. 175,123 parentheses 1 minus 0.13, close the parentheses, and raise that to the 7th power. And so the value of the equipment is $66,019. And then because this is a 9, we're rounding this number up, 59 cents. Okay? Make sure you set these up correctly. Here, here, and here, because you definitely get points for those. All right, last page that we have to do is all about the graphing. Now, it's going to be very, very, very important for you to remember, okay? Vanilla exponential. Vanilla exponential. We have to remember that the domain is all real numbers. We have to remember the range, okay, is going to be y greater than 0. And it has the asymptote at y equals 0. Now, we have 4 of these to do, and on each one you're going to have to identify the domain, range, and asymptote. So let's do that part first, and then we'll come back and graph. Immediately, for the domain, in each one of these. Remember, if domain is all real numbers, no matter where you shift these graphs, okay, it's still going to include all real numbers. So immediately for each one of these, go to your domain and write all real, and I'm going to shorten numbers as that right there. Okay? Domain, all real, and then numbers. Come down here. Okay? You want to get these points, so make sure you do that. All real numbers. All real numbers. All right. Now the ranges is what changed. Okay, depending on where you shift. Now you'll notice that this one right here, this is 3 times 1 over 3 to the x power. And I'm just going to rewrite it a little bit bigger. 3 times 1 over 3 raised to the x power. Okay, well, there is no vertical shift in this case. So the range is going to stay the same. Y greater than 0. And the asymptote stays the same. Y is equal to 0. Over here, let me move this down, we have, I'm just going to rewrite this so you can see y is equal to 2 to the x minus 2 power. That's a shift to the right 2 units. So remember, range deals with up to down. If you're shifting right, that doesn't affect up and down. So y is still greater than 0, and y is still equal to 0 for the asymptote. Y equals 2 to the negative x power. Remember, you want to rewrite this as y is equal to, instead of 2 to the negative x, write it as 1/2 raised to the positive x. Well, you're not shifting anything. So once again, the range is y greater than 0. The asymptote is y is equal to 0. Now let's look over here. Y is equal 2 times 3 to the x minus 2 is what that says, and then plus 1. So this is a shift right 2 units, and it's a shift up 1 unit. Okay? So the range now changes. The range, which was y is greater than 0, becomes y is greater than 1. And again, that's because you went up 1 unit. The asymptote also shifts, and it becomes y is equal to positive 1. Okay, it's 1 unit up from y equals 0. Now that we have those written out, let's go ahead and start graphing, and we're going to use our calculator to help us. First thing that goes on your graph paper, okay, is going to be your horizontal asymptote. Y is equal to 0. That's right here on the x-axis. And you should label this. And label that y equals 0. Now we're going to use our calculator to get some other points. This is 3 times, in parentheses, 1 divided by 3, close the parentheses, caret x. And I'm not so much interested in the graph as I'm interested in the table of values. And you can see 0, 3. So over here, 0, 3, and label that point. 0, 3. I see 1, 1. So come over here and label that. 1, 1. I see negative 1, 9. Over here, then up, and label that. Negative 1, 9. Now that you have your 3 points, you can draw your graph. And remember, it hugs the asymptote there. Okay? This is exponential decay. We knew that because the base here, 1/3, is less than 1. All right, let's look at this one now. Y is equal to 2x, 2 to the x minus 2. Clear that? The way we're going to type this into our calculator, parentheses, x minus 2, close the parentheses. Okay, that is y equals 2 to the x minus 2. Go to your table. Plot some points. 0, 0.25. Oops, excuse me. We want to put our horizontal asymptote on there. Don't forget that, Mr. Chapman. There we go. Let me move this over. And remember, you want to label this y equals 0. Now let's plot our point. 0, 0.25 is right here. 1, 0.5 is kind of right there. 2, 1. And I haven't been labeling my points. I want to do that. 3, 2. And I'll go back and do that. I want to see one more point here, because now we're getting some good points. 4, 4. And 5, 8. Notice I put a bunch of points on this graph because there's a whole bunch of good ones. Okay, so we're hugging the asymptote, and then we start hitting our points. Now let's label some. Again, this one right here was 5, 8. This one right here was 4, 4. This one right here was 3, 2. I only need you to label 3 points for me. Okay, over here y equals 1/2 raised to the x power. Again, horizontal asymptote, y equals 0. Label it. And then let's plot some points. 1/2 raised to the x. I like these points kind of up in here. Still like my 0, 1. That's a good one to do. 1, 1/2 right there. Here's 0, 1. Here's 1, 1/2. Negative 1, 2. Negative 2, 4. I'm going to go ahead and keep on labeling some of these points. Okay, a negative 3, 8, and then we're kind of done. So comes down, and then it starts hugging that asymptote. There we go. Last one, y is equal to 2 times 3 caret. The x minus 2 needs to be in parentheses. Okay, this right here, you need to put parentheses around there. And then the plus 1. Don't forget the plus 1. That's important. And so here's our table of values. Y equals 1 is our horizontal asymptote. So that the horizontal asymptote, which has been on the x-axis for the other 3 problems, now gets shifted up. And now we're going to pick some points to plot. 0, 1.2-ish is going to be right there. Come on, pen. Let me fix that. 0, 1.2. Okay. 1, 1.6. Kind of hard to differentiate there, but we can label it 1, 1.6 repeated. This was 2 repeated. 2, 3 is a much better point for us right there. 2, 3. 3, 7 we can definitely stick on here. There it is. And that's good to go. Okay, so it hugs the asymptote, starts hitting our points, and shoots up. Okay? And you're done. That's all you have to be able to do. Notice when you have exponential growth, again, when your base is greater than 1, you're skyrocketing up. Okay? When you have exponential decay, that's when you're coming down and getting closer and closer to 0. So I hope you all study hard. You need to remember this stuff up here, and you need to remember that exponential growth, y equals a times 1 plus r to the t. Exponential decay is y equals a times 1 minus r to the t. This formula right here will be given to you.